This video corresponds with lesson number 5 in Unit 4A, dealing with how to simplify radicals. This video will walk you through a couple of basics with radicals, including the basics of how to simplify them, as well as how to add and subtract terms with radicals, as well as multiply and divide things with radicals as well. But before you can do operations, you need to know how to simplify. So that's what we're going to take a look at first. There are two ways that you can go ahead and simplify radicals. I'm going to be using one method more than the other in this video, but there are a couple ways you can simplify things. You choose whichever works better for you. So the first method is to know your perfect squares. So square root of 72, the goal is we want to break it apart into as many things as possible that will perfectly square root out. That's how you simplify radical. It's not just about punching it in the calculator and getting some randomly gross irrational decimal. The goal is to see if there's anything that has a perfect square factor, can we take it out? So 72, if we try to break that down, that actually breaks down into 36 times 2. So what I can do is I can rewrite this. Square root of 72 is the same thing as the square root of 36 times the square root of 2. Well, I know the square root of 36, based on my knowledge of perfect squares, is 6. Square root of 2 I can't do anything with, and there's no other way to really break 2 down other than an infinite series of 1s and 2s. Square root of 72 would be the same as 6 square root 2. That's how I can break it down using my knowledge of perfect squares. Now, if you're rusty on those, I do suggest trying to know some of those off the top of your head and being able to recognize how to break them down, because I think this method, that first method, is going to be faster when we start doing operations, and you're going to see throughout this chunk of the chapter and in other chapters we do more complex things with radicals. So the less you have to show in terms of how to simplify, the quicker that will be. You can, however, use the factor tree method. This is probably the method that some of you may have learned in your Algebra 1 class or in previous math classes. This is where you kind of do the same thing, except the goal with the factor tree is to break it down as far as you can go into all of its little prime components. So 72, like we just said, you break it down any way that you possibly can. So 36 and 2. 36 breaks down into, let's say, 9 and 4. You get a couple of 2s when you break down to 4. You get a couple of 3s when you break down to 9. Your goal is to break it down into as many primes as possible. 3s and 2s are nothing but prime numbers, so we stop, and we're looking for pairs of primes to pull out. So I have a pair of 3s and a pair of 2s. I take those pairs, and I pull them out. Whatever primes are left over stay underneath the root. So in this case, we had that extra 2 that broke apart in the first place. That would go back under the radical symbol. I combine what's on the outside, and I still end up with the same answer, 6 square root 2. So they both work the same way. I think what you'll find is if you commit to learning the perfect squares, it'll make it much faster for you to break these numbers down. And as I go throughout this video, I'm going to keep emphasizing that first strategy so you can see how quickly it can be used, and plus it'll probably help you start memorizing some of these number patterns. So that's how we simplify. We're going to use that now to be able to add and subtract radical expressions as well as multiply and divide. So underneath here you can see we're going to take a look at how to add and subtract. To add and subtract radicals is the same idea as trying to add and subtract general like terms. So for example, if I wanted to add or subtract terms like 2x and 8x, I could put it together and make 10x. But if I wanted to put together like 2x minus 8y, I couldn't put them together because I have two different variables. Same idea with radicals. If you have the same radical as part of each term you're trying to add or subtract, you're able to combine them. So if I look at the first example here of 2 square root 7 plus 8 square root 7, the fact that they both have a square root of 7 means I can immediately just add them together. It's essentially like they're like terms. If I have 2 square root 7, I add another 8 square root 7, I get an answer of 10 square root 7. All I care about are the numbers on the outside of the radical. Those are the ones I'm going to combine. The square root of 7 does not change. Do not turn that into square root of 14 or some other bad math. The square root of 7 stays the same when you add or subtract, whatever the case may be. Now, if we look at the subtraction problem here, at face value, 5 square root 18 minus 4 square root 8, I can't put that together because the radicals are different. I have an 18 and an 8. However, if the radicals are different, what you have to make sure of, and this goes for any sort of operation we do with radicals, you have to make sure they are simplified down. Because if they aren't, you might be able to combine them if you work your way through the simplification process. So if you look at number 2 here, 5 square root 18 minus 4 square root 8, both of those numbers under the square root will simplify down. So when you do this, you want to basically try to simplify one thing at a time. So the first thing I'm going to focus on is the 5 square root 18. 5 stays out front. I want to break down square root of 18. Using my perfect squares method, that breaks down into 9 and 2. So I'm going to write that as 5 times square root 9 times square root 2. Well, we know square root 9 is 3. Square root 2 stays put. And I can eventually rewrite it as 15 square root 2. So all I'm doing there again is I'm just showing each of my steps. I broke the 18 apart in a way that would give me something that's easily square rootable, so I can simplify it down pretty quickly. I'm now going to do the same thing with negative 4 square root 8. So I'll bring down the negative 4. 8 breaks apart into square root of 4, square root of 2. Well, we know the square root of 4 is 2. I can rewrite 4 square root 8, negative 4 square root 8, I should say, as negative 8 square root 2. Now that I've simplified both of the radical expressions, if you look at what's left here, I now have like radical terms. So 15 square root 2 minus 8 square root 2 can now combine together. Subtract the outside numbers. 15 minus 8 is 7. We keep the square root 2 because that's how adding and subtracting works. And we have ourselves a simplified final answer. So with adding and subtracting, you have to make sure you have the same radical. Okay, you cannot have different radicals and try to mush it together. You'll see with multiplication and division, you don't necessarily have to worry too much about that, but still the same idea in terms of making sure everything is simplified. So let's go ahead and take a look at we'll look at division first, and then we'll finish off with multiplication. So in order to divide things with square roots, first and foremost, you're going to see them typically written as a fraction. So here we have the square root of 9 over 100. Property of square roots is if I have a full fraction underneath a radical, I can split it apart so that each the numerator and the denominator can be square rooted. That's just a property of how radicals work. So I can split it apart like so. Now, if I know my perfect squares really well, which I do, square root of 9 is 3, square root of 100 is 10. Can't do anything with 3 over 10, that doesn't simplify any further. So I'm done. Square root of 9 over 100 is the same as 3 over 10. That's about as basic as it can humanly get, if they perfectly square root. Now, what we want to do here is take a look at number 2, where it's kind of broken apart for us. But we want to see again, is everything simplified? How much can we possibly do? So let's take a look at our numerator here, 5 square root 6. If I try to break 6 apart, the only way to do that would be square root of 2, square root of 3. Since neither of those are perfect squares, I'm just going to leave it alone as square root 6, because it doesn't really break down at all. We can just kind of leave it be. Now, if I look at 3 square root 24, we're going to keep the 3 out front. Square root of 24 would be the same as the square root of 4 times the square root of 6. Well, we already know the square root of 4 is 2. So I'm going to rewrite the denominator as 3 times 2 square root 6. And we're going to have 5 square root 6 over 6 square root 6. Now, if I look really carefully here, you'll notice that I have the same thing on top and bottom, a square root of 6. Now, the fact that these are connected by multiplication in each numerator and denominator allows me to cancel out stuff that's in common. So, square root of 6 on top and square root of 6 on the bottom will cancel. That'll leave me with a final answer of 5 over 6. For what you know to do right now, you're not allowed to have any form of square root in the denominator of a fraction. That is a math rule, kind of like negative exponents. You're not allowed to have that as part of your answer. Same idea. You cannot have a square root left over in your denominator. So for what you know right now, your goal is to see if they cancel out. You'll learn in the next lesson a process called rationalization, where if you can't get them to cancel, how we can find a way to get rid of those square roots in the denominator. But for right now, you're just simply trying to break things down. Again, if you break things down correctly, you will get the square roots, at least in the denominator, to cancel out. If you have them left over in the numerator, that's totally fine. That's not a big deal in math, but in the denominator, that has to go away. So that's division kind of in a nutshell. Again, your goal is just to break the numbers down, numerator, denominator, simplify as much as you can, cancel what you can, And again, in division, as long as you don't have a square root in your denominator, you're in great shape. The last chunk we have here is multiplication. So we're going to use the same multiplication properties you've learned 100 times over in algebra and pre-algebra, etc. The key is making sure we combine numbers correctly and simplify things correctly as well. So if you take a look at 3 here, I have 2 square root 3 times the expression square root 6 plus 5 square root 15. If I treat this like a normal problem, we're going to distribute. The 2 square root 3 will affect both terms inside the parentheses. What we need to make sure, though, is that we combine the right types of numbers together. So, when you multiply, the key is really this. If the number is outside of the radical, it can only multiply together with numbers outside the radical. If the numbers are inside the radical, you can only multiply that with things inside the radical. So here's what I mean by that. If I say, let's look at the first wave, 2 square root 3 times square root 6. 2 is the only number I have that's outside in that combination, so it's going to stay out front. Square root 3, square root 6, those will combine back together because they're both under the radical and can make square root 18. Now we look at the second wave here, 2 square root 3 times 5 square root 15. 2 and 5 will go together because they're both on the outside, and again, we are multiplying here, so 2 times 5 is 10. Square root of 3 and square root of 15 would multiply together because they're both under the radical, so that makes 45. Now, when you do this, again, your goal is to make sure it's as simplified as humanly possible. So, theoretically, you could try to simplify things before you even start the problem. I think it's easier to kind of combine things first and then break it apart once you've combined what you can. Totally up to you, however you see this working. So, long and short of it, we're going to treat this just like the problems we did on the previous slide, where we're going to break each of the 2 terms down, see how far we can simplify it, and if we can add them together, great. If we can't, then we can't. So, let's look at 2 square root 18. Kind of already saw square root 18 before. We know that's square root of 9 square root of 2. So, that turns into 2 times 3, which ultimately gives me 6 square root 2 for that expression. Now we'll do the same thing with 10 square root 45. So I bring down the 10. 45 would break apart into square root of 9, square root of 5. So I'd have 10 times 3, square root 5, which gives me 30, square root 5. Now, I've simplified these down as much as I humanly can, and yet I still don't have the like radicals. Not the end of the world. If they don't match up, then they don't match up. You circle it, you're done with it. That's your final answer because you can't combine it together. They don't have the same radical. That will happen with some of these problems, but you've now simplified it as much as you humanly can. And that would be finished. In multiplication, maybe it's not necessarily distribution. It's just here's 2 random terms. Let's put them together and see what happens. So, with number 4, I have negative 6 square root 5 times 8 square root 20. I can rearrange this whole problem because everything is technically connected by multiplication. Negative 6 square root of 5 is being held together with a multiplication symbol. Same with the 8 and the square root of 20. It's all one gigantic multiplication problem. So what I'm going to do here is I'm going to rearrange it. I'm going to put my outside numbers together, so negative 6 times 8. And then I'm going to put my square roots with each other. Square root of 5 times square root of 20. So once again, I'm going to combine what I can. So negative 6 times 8 is negative 48. Square root of 5 times square root of 20 is a square root of 100. Once again, some of you might find it easier to break things down as you go. Some of you might want to put it all together first and then re-break it apart to see what happens. Some problems, it works out both ways, easier than the other. It just kind of depends. But again, I like combining stuff first. If I look at the square root of 100, well, we know what that is. It's 10. So I can change negative 48 square root of 100 to negative 48 times 10, which gets me a final answer, a nice answer, of negative 480. Sometimes when you do these problems, when you're combining things, especially in multiplication and division, you saw in a couple of these here, the radicals just flat out disappeared once you started combining and simplifying. That can happen too. Sometimes they're left over. That's fine. It just depends on what type of terms you have. So that's a review here of your basic operations, how to simplify, how to add, how to subtract, divide, and multiply.